record, minimize, and turn on my sketch pad. All right, what do you got?
Okay, so it's a complex fraction, so it'd be -6 minus square root -12 over 48.
Okay, and we're probably supposed to put this into A plus BI format?
Yes.
Okay. First, let's handle the numerator.
What?
I said first, let's handle the numerator.
Okay.
The toughest part about this whole problem is this right here. So what does that turn into? Square root of -12.
It'd have to be 2 square root 3i.
Yeah.
Or 2 square root 3.
Yeah, the way it sounds like you know already how to do this, but I would separate it into three things like that.
Mm-hmm.
That's I, that's 2, and that's root 3.
Yeah.
So the proper way to write it would be 2 root 3i. So now what we have is -6 minus 2 root 3i all over 48. Now, I can simplify that a little bit. What can I do?
Can you do the 48 and 6?
No, but I can divide top and bottom by 2.
Okay.
So I immediately reduce it to -3 minus root 3i all over 24.
Mm-hmm.
With me?
Yes.
Now, we still have to put that in A plus BI format. Okay? Mm-hmm. The fact that we have a single term in the denominator means we can separate it into those two fractions. That fraction and that fraction. So
okay.
Let's split it up into those two fractions. What do you have? What's -3 over?
So it'd be -3 over 24.
Which is the same as -1/8.
Oh, yeah. Yes.
What's the rest of it?
1/8 minus 3 square root 3i over 24.
Actually, you need to do it this way. In other words, that is A.
Oh, and that's the B.
That is B. In other words, you need to separate the number part out completely. So you end up with root 3 over 24. And then you've got the I. So this right here is the preferred answer. If you gave this as an answer, you might lose a point, maybe nothing. Of course, if you gave that as an answer, you hadn't simplified it much at all, and all the way through. In other words, the best answer is this one down here. Okay?
Yep.
What else?
And then, so it'd be square root of -8. And then parentheses, square root -3 minus square root 5 and parentheses.
Like that?
Yes.
Okay. It's the first thing we want to do.
You change the 8 into 2 square root 2i.
Yep. 2 root 2i. Okay. How about the -3? What's that?
Can you distribute that into the next?
Yeah, but hold on. Let's change the -3 to what it should be.
Would that just be 3i?
Root 3i. In other words, here's what we're doing. Whenever we have a number like that, we'll always take the I out first. There, taking the I out, what's left? The root 3. So now we have I root 3. Okay? Minus root 5. And now we can distribute it. So multiply that times that.
This would be 2 root 6i squared.
And what is I squared?
That's -1.
Or I can just put the negative sign right there.
Oh, yeah.
Okay? Now, what is that times that?
So it'd be -2 square root 10i.
And is that our final form? Is that our final answer? And is that in A plus BI format?
Yes.
Yeah, A is that. B is that. And there's the I.
Mm-hmm.
Okay.
Okay. For the next one, it would be parenthesis 3 square root -7.
I'm sorry. I meant to say something on that first one. Can you give me that first one again? It was the last one we did.
The full problem, or
yeah, from the start.
Okay, it would be square root -8 parentheses square root -3 minus square root 5.
Okay. Notice what happens if we don't turn these into imaginary numbers first. And you try distributing that. What do you get?
You get -24.
Negative times a negative is a positive.
Oh, I see.
In other words, you got to be a little careful. This is not the same as if I turn these into i's first. Notice when we did it the first time, we ended up with 2 root 6. We ended up with -2 root 6i. No, we lost the I because we had an I squared, right?
Mm-hmm.
Whereas this way, we end up with +2 root 6. So you want to turn these things into the imaginary number before you start multiplying them by other imaginary numbers. Because if you just multiply the insides together, which is what they teach you to do, it turns positive and you lose the negativeness of it.
Mm-hmm.
So be a little careful. So always make your first step extracting out the I before you multiply. And always know that I squared is equal to what?
-1.
Right. So if I turn these into i's first and then multiply them, I have an I squared, which turns the whole thing negative. Whereas if I multiply them first, I have a +24, and that's just equal to a +2 root 6. So it does make a difference. All right, go ahead on the next one, Corey.
Okay, the next one starts parentheses 3 square root -7 and parentheses, and then another parenthesis 2 square root -8 and parentheses.
Again, same problem. If we don't turn it into I, we're going to get a wrong answer. In other words, one way to do this, it looks like it would be 6 root 56, correct?
Mm-hmm.
It's not. That's the bad way to do it. Now let's do it the proper way and see what we get.
So you can break -8 into 2 square root 2.
Okay, that's fine. So 2 root 2I.
Yeah.
And how about the first one? Go from left to right.
I don't think you can do anything with the -7.
Extract an I out of it.
You can be -7i.
Root 7.
7.
It's not -7i. In other words, once again, negative, if you start there, extract the I as your first step, leaving the rest of it just a 7, which gives you root 7i. Okay, now that I've got the i's, I don't risk making that mistake that I made in the first line. I'm going to put that is not equal to that. Okay, now go ahead and do the multiplication. What do you get?
You get, don't you need to do the 2 times the 2 root 2i?
Yeah. Excuse me. I was wondering why we weren't getting the right number.
So it'd be, yeah, okay. It'd be 12 root 14i squared.
Which is -1.
So it'd be -12.
-12 root 14. Now, what does this become?
That would become
12 root 14. Totally different answer.
Yes.
Based strictly on the fact that the second way, the correct way, extracts the i's first to avoid this -7 times -8 turning into a positive 56. It's a subtle thing, and it's puzzling to a lot of math students because there's not many math things where that appears to be wrong if you do it the way they've taught you to do it all along. In other words, they've taught you for a long time that is equal to this. Well, not when A and B are negative, it isn't. Okay? When A or B are negative, you've got to turn it into the imaginary number first, and then operate with it. Okay, what else you got?
Parentheses 2 plus I, and parentheses squared, minus 1 plus 2i squared. In parentheses, yeah.
Okay.
So it would be 4 plus I squared, which is negative.
Hold on. Make sure you do that right. That's the most common mistake in algebra. What this really is 2 plus I times 2 plus I. That is not 4 plus I squared. FOIL it. What do you get when you FOIL it?
You get 4 plus 2i plus 2i plus I squared. So it'd be 4 plus 4i plus I squared.
Well, turn that I squared into, always reduce. Anytime you get an I squared, turn it into a -1.
Okay, so it'd be 4 plus 4i minus 1.
Right, now you can combine the 4 and the -1. Those are both real numbers. So that's what you get. Okay, so this is what 2 plus I squared is. Now, tell me what 1 plus 2i squared is.
It would be 1 plus 2i plus 2i minus 4.
Very good. That's fine. Because that turns into 4i squared, which turns into minus 4.
Mm-hmm.
Combine that.
So it would be -3. So -3 plus 4i.
So that's what the problem has turned into. What's the answer?
Would it turn into an addition problem?
Okay. How do you do that?
Because the negative and the -3.
Yeah, your next goal is to remove the parentheses. And one way to do that is to turn it into an addition problem. But once I do that, I have to change the sign of everything that follows in the parentheses, right?
Mm-hmm.
So that becomes positive, and this becomes negative.
Mm-hmm.
And now I can remove the parentheses. And I don't need two positives in a row, so I can remove that positive. Now, perform the operation. There's no more parentheses.
So it would just be 6.
That's it. That's the answer. Okay?
Okay.
Do you have answers on these?
I do not.
Okay.
And the next one's 69. So the question is, what is I? And I is an imaginary number, right?
No, I has a very strict meaning. It's the square root of -1. And that makes it imaginary because there is no square root of -1. But there is in the complex realm of numbers. In other words, you have real numbers, which includes all the numbers you're used to, and then you have the complex world of numbers. That includes I.
Mm-hmm.
In fact, they have a way of graphing it where x-axis is the real and the y-axis is the imaginary.
Mm-hmm.
Okay? So if you were graphing the number 2 minus 3i, you'd graph the real part right there at 2, graph the imaginary part right there. So the coordinates on that would be minus 3i. So the coordinates on that thing would be 2, minus 3i. And notice this is not an x and y scale. It's a real number and imaginary number. So any complex number that is of that form, you can graph on this coordinate plane. And
Okay.
A is just the horizontal axis, and B is the vertical axis.
Mm-hmm.
Okay? Did that answer that question?
Yeah.
Okay. Pretty sure the only answer it can be is square root of -1.
Yeah, I think that's what it wanted.
Uh-huh.
And then the next one is explain how to add complex numbers and provide an example.
Okay. Let me write a couple of complex numbers here. You tell me how you think they should add.
You just add the real numbers and then add the i's together, just like you would add a variable.
Exactly. That's the answer. In other words, it's the simplest thing in the world. Same way you would add x plus y In other words, if I had an x plus a y and I wanted to add to it 3x minus a y and I wanted to add both of them together, you just add the x's, add the y's, and you get that. No different. Same thing with subtracting complex numbers, which probably is the next question.
The next question is explain how to multiply complex numbers.
Okay.
So you just multiply it like square roots?
No, you'd FOIL it like you would any binomial. You know what I mean by FOIL? They don't teach FOIL everywhere anymore, so you might not know what I mean by FOIL.
First, outer, and then last.
That's right. I prefer the term ET, which means you take every term and multiply it by every other term. ET works better if one of them's a trinomial. Notice that if I try to use FOIL on a trinomial, it doesn't work. FOIL is strictly for a binomial times a binomial. But that's what we have here, so let's go ahead and FOIL it. What do you get?
You would get 9. One sec, I'm writing this down.
Always start from the left and do every term fully before you go to the next term.
So it'd be 9 minus 3i plus 6i minus 2i squared.
Now simplify that.
So it'd be 9 minus 3i plus 6i plus 2.
Hold on. First of all, you can simplify that. Simplify those.
That would be 3i.
Okay.
Plus 3i. And that would
what's 2i? What's minus 2i squared equal to?
That's plus 2.
Okay, and now you can combine the numbers. So you end up with 11 plus 3i. In other words, you always want to combine the real parts and the imaginary parts and get to a point where you're putting it down as a plus bi. Okay? So, addition, subtraction, and multiplication are exactly as you would do it with other variables. The difficult part is division. You got one like that? I want to make sure we cover it before your half hour is up.
Yeah, it's number 62.
Is it a specific one you want to give it to me?
I'll explain how to divide complex numbers. That's it.
Okay, well, again, I'll just make one up. We'll put a coefficient in front of it just for the heck of it.
Okay, you'd have to find the conjugate of the denominator.
In other words, this is not a division problem. It looks like a division problem, but it isn't. What it is a problem where you have to make the denominator real. Kind of like over here on the right. That, you see what I just wrote there, 1 over root 2? That is also not a division problem. The only thing I have to do to that is rationalize the denominator. And I do it by multiplying the entire fraction by the number 1. And in this case, the number 1 is root 2 over root 2. And that turns it into root 2 in the numerator and 2 in the denominator. That is a satisfactory number. Got a real, or excuse me, it's got a rational denominator. Well, when you're dealing with complex numbers, your goal is to realify. Instead of rationalize, realify. And you do it by using the conjugate. Okay? So what am I going to multiply this fraction by? And remember, I've got to multiply top and bottom by whatever it is, because that's the number 1.
It would be 4 plus 2i.
Exactly. Same terms, different sign. Means I got to do the top by 4 plus 2i. Now, an amazing thing happens always when you multiply a complex number by its conjugate, it turns real. Go ahead. Multiply the bottoms.
It would be 16 plus 4.
Yeah. In other words, the two middle terms that you usually have are always going to cancel one another out and leave you with just two real numbers. Now, you still have to do something with the top. So go ahead and you got to multiply those tops. In other words, you can't put the top as this multiplied by that. So go ahead and simplify the top.
It would be 12 plus 14y minus 4.
Simplify that.
You can take out a 4. No.
Well, first of all, combine the two real numbers.
Oh, minus...
Every time you do one of these, this is exactly what it's going to look like. You're going to have a real number on the left, and you're going to have a real number on the right. So you always have to combine those.
So it would be 8 plus 14y over 20.
14i?
Yeah.
Okay, now simplify that, because I can simplify that further.
Take out a 2.
Well, when you say take out a 2, what you really mean is divide top and bottom by 2.
Yeah.
Which is the same as multiplying that fraction by 1 or dividing it by 1. Just like you can multiply any fraction by the number 1, you can divide any fraction by the number 1. So if I'm going to divide top and bottom by 2, what do I get?
You're going to get 4 plus 7i over 10.
Now, that's almost the final answer. The problem is that is not in A plus BI format. So what's the final answer?
Would you have to multiply top and bottom by 10?
No. Just separate it into two fractions.
Oh, it'd be 4 over 10 plus 7 over 10i.
Right. And then you do need to take the 4 over 10 and reduce it to 2 over 5. So that's the final answer. And notice there was quite a few steps. And also notice that what we get has no resemblance to that. We get an A plus BI answer, always. And it usually doesn't look anything like the top. Now, I'm going to give you one that's pretty straightforward, but there's one that kind of can give people a little problem. How am I going to do this?
So it would be over -1, right?
What now? No, that's I. That's not -1. That's square root of -1, but we don't want to turn it into that. You don't ever want to really turn in I into the square root of -1. If you spot the square root of -1, you want to turn it into I always. You don't want to go the other way usually. No, this is this a division problem?
No.
No, it's a realifying the denominator problem. We've got to make the denominator real. So what can I multiply the denominator by to turn it into a real number?
I?
Yeah. In other words, I don't have to worry about the conjugate. And if I multiply the bottom by I got to multiply the top by I. Now, actually, it would make it a little bit simpler if I do multiply it by the conjugate, because then the bottom ends up being +1. And the numerator ends up being minus 3i minus 2i squared, which turns into 2 minus 3i. So normally you multiply by the conjugate, but when it's just I and there's no real part in the denominator, you can get away. Notice that I could have multiplied it by just I.
Mm-hmm.
And the difference is that turns into a -1 in the denominator and pluses in the numerator. You still end up getting the same answer. But you have to go through one additional step, which is to turn that into where the negative goes in the top, which means switching them, switching places.
Mm-hmm.
Okay, what else? It's 7 if you want to put, it's Jessica, right?
Yeah.
Okay, she ready to go?
Yep.
Okay, hi Jessica, how are you?
Good.
Okay, so you're not doing imaginary numbers tonight?
We are.
You are doing them, okay, cool. What do you got?
Okay.
I would have thought you would be. Usually when they talk about complex numbers, that's all they talk about for about a week, and then they go on to something else.
Yeah. That's how we're starting.
Yeah.
Okay. Start with, in parentheses, -2 plus square root -11 parentheses squared.
Okay. Now, the best thing to do whenever you see square root of a negative number is to immediately turn it into a complex number. So what is the square root of -11 if I want to talk about it in terms of I? In other words, square root of -11 equals what?
11i.
Yeah, no, root 11i. Here's the way I do these. Very first step, I always take out the -1, which leaves the positive number like that.
11.
And that is equal to root 11i. With me?
That makes so much more sense.
Okay. Now we're going to use that in place of root -11. And it does matter. It will give you a different answer if you try to do this the normal way. So what we now have is this, -2 plus root 11i squared, meaning multiply it by itself.
Uh-huh.
And now FOIL those two.
4 minus 2 root 11i.
Hold on, excuse me 1 second. What the heck happened? 4, I think, and hold on a second. Let me close this down. That's the only way I have of fixing it. I apologize.
It's okay.
Computer goes on. Let's try that again. Write down. Let me try one other thing, if you don't mind. Just hold on a second. That's unplugging and plugging back in my drawing tab. Hold on. Unplugging it was easy enough. Plugging it back in, you got to see where the slide is. The USB port. And I'm having a terrible time finding it out. I wonder if I have it turned around. Hold on. Wow, just a second.
It's okay.
Unplug my printer. All right. I'm going to close that out again and start again. Hopefully that will have rectified the problem. If it didn't, -2 plus minus 11 squared. Was that the problem?
Yeah.
Okay. So this became minus 2 plus root 11
11i.
times itself.
Yep.
And then FOIL it again.
When I finished foiling, I got 4 minus 4 11i plus 11i. That's what I got.
Didn't you get 11i squared?
Yeah, that's what I meant.
Hold on 1 second. I don't think that's right. Let me go back and do it. So that times that is 4. That times that is minus 2 root 11i. That times that is minus another 2 root 11i. And finally, the last one is plus 11i squared.
Yeah.
Now, okay, I must have missed the I the first time through. Now, you can always change the I squareds into what? What's I squared equal to?
-1, so it's minus 11.
So that goes to minus 11.
So,
Now I can combine that real number with that real number, and I get minus 7. And combine the two middle i's, and I get minus 4 root 11i. And there's your final answer.
okay.
And it's in the proper format, a plus bi. Sometimes you'll get an answer that has a denominator. Here, let me give you an example. Suppose I had this. Can you put that into a plus bi format? Because the numerator's in that format, but the denominator isn't. So I need to separate this into an a, and then a b, and then an I.
Would 4 be A, 5 be B?
No.
No. Okay.
A would be that part of the fraction, 4/5.
4/5 plus
B would be that part of the fraction, 3/5. And then there's the I. And that is in perfect a plus bi format, where a equals 4/5, b equals 3/5. So you have a plus bi.
Okay.
Okay? So you only need to worry about this is if there's a real denominator. And in other words, if you gave that as an answer, you might not lose points. But if the instructions were give your answer in a plus bi format, you'd lose at least a point.
Okay.
Okay? We'll probably come across some here as we go. What else you got?
5i over 2 minus I.
This looks like a division problem. It really is not.
So you multiply top and bottom by 2 plus I.
You got it. It's what I call realifying the denominator. Much the same way that you rationalize a denominator. You know, if I start out with 1 over square root of 2, that's not a division problem either. That's a rationalize the denominator problem. I do it by doing that, and I turn the irrational number into a numerator. And that's the answer that most mathematicians would want, not 1 over root 2. So just as this is not a division problem, nor is this. So what's the bottom become? The bottom always turns into a real number.
Yes.
What's that bottom turn into?
When I did it, it got...
The two middle terms should cancel one another.
I got 5.
Okay, good. You get 4 plus 1.
Yeah.
Or 4 minus a negative 1.
Which is plus 1.
Right. Now you still have to do the numerator. What's the numerator become?
10i plus 5i squared, which...
Now turn that into an a plus bi format.
So that'd be 10i over... Wait, first we need to simplify the I, because there's a square.
I would turn that into negative 1 first. So this becomes what? Negative 5, right? In other words, 5i squared is equal to negative 5. With me?
Okay.
Okay. And then I'm going to switch the order of them. So I'm going to put the negative 5 first plus the 10i.
Over 5. So then negative 5 over 5 plus 2.
Go ahead and simplify everything down. In other words, actually is all you need to do. You don't need to really separate this into two fractions. You just need to divide top and bottom by 5. What do you get when you do that?
Negative 1 plus 2i. That's it.
That's your final answer. I don't any longer have a denominator to worry about.
Okay.
Or it's 1. But in other words, it separates itself when you can fully divide the top by whatever number's in the denominator. Then you don't need to worry about splitting it into two fractions.
Okay.
Okay. What else?
Let's look. Okay. 48. Parentheses negative 4i parentheses squared minus parentheses 1 plus 2i squared.
And this is all squared like that?
Yeah.
Okay. Let's do the first part on the left.
So that's just negative 16i squared, which is just 16.
Actually, the negative 4 is part of what's being squared, correct?
Yeah, so it'd be 16.
Okay. 16i squared.
So it'd be, yeah, which is negative 16.
There you go. Now square this part.
1 plus 2i times 1 plus 2i.
You can just do it one part at a time if you want, and I'll write whatever you say.
Yeah. And so that's 1 plus 2i plus 2i plus 4i squared, which is 1 plus 4i minus 4.
And now combine the real parts.
Negative 3 plus 4i.
Okay. And all of that is being subtracted from a negative 16, like that.
So you
now remove remove the parentheses.
Couldn't you get rid of the minus and switch all the signs to make it negative 16 plus 3 minus 4i?
Yep, that's exactly what I was going for. In other words, when you remove the parentheses, that's what you're left with. Now combine the real parts and give me a final answer.
Negative 13 minus 4i.
Yep. In A plus BI format.
Perfect.
There was a problem that came up with your brother. I think we should go over it.
Okay.
What's that equal to? If you did it the normal way, what would it be equal to?
So that would be root 7i times root 3i, which is root 27i.
Okay, that's the proper way.
Yeah.
Gives you what?
Root 27I squared.
Which gives you what?
Root 27 times -1, so it's...
Yeah. It's actually 21, not 27.
Yeah,
3 times 7 is...
Yeah. My bad.
Okay. Did you see how I got the negative sign in front?
Because
I ended up with root 21I squared.
which is -1, so -1, so it's just negative.
Right.
Okay.
Now do it the top way using what they've taught you all these years, which is root A times root B equals root AB. Right? Haven't you learned this
Yeah.
for everything?
Yeah.
Use that technique to do the top.
So then it's just root -21.
Why is it negative? It's negative
I.
7 times -3. Now forget the i's for a moment. Just multiply the 2. In other words, multiply the A times the B.
So that's just 21.
Right. That's not the same answer as that.
Huh.
So when you do it the old-fashioned way, you don't get the right answer. When you have a imaginary number, you need to convert it to the imaginary number immediately. Otherwise, it gives you a different answer.
Huh.
Come on, outside. Yeah, it's a weird oddity, because usually when they teach you rules in math, they're applied to all numbers. But in this case down here does not apply if you have negative numbers inside the radicals.
Huh. Okay. That's weird.
Yeah, it is weird, but the bottom line is convert everything to an imaginary number right off the start so that you don't ever run into that particular problem.
Okay.
Okay, what else you got?
2, 3 plus 2I plus -5 plus 7I. I think you just combine like terms, honestly.
Exactly. What's the answer?
-2 plus 9I.
Adding, subtracting, and multiplying complex numbers is exactly the same as
real.
You had an X in there instead of an I.
Okay, that's
The only thing that's different is dividing complex numbers.
okay.
And you already know how to do that. If I'm going to divide that by this, what am I going to do? That's not really a division problem.
You multiply by the conjugate, so it'd be multiply both halves by 5 plus 4I.
Exactly. Top and bottom. And what happens on the bottom is you always end up with a real number. Whenever you take a complex number and multiply it by its conjugate, it turns it real. In fact, that turns into 25 plus 6, 41. And then the top stays imaginary. You have to do you have to FOIL this term by this term. And you still do end up with an I in the numerator, but that's where it belongs. In the same way that math doesn't like irrational denominators, it doesn't like complex denominators either. So whenever you're dividing or have an I in the denominator, you want to realify the thing. And realifying it means multiplying top and bottom by the conjugate of the denominator. Okay? Now, that covers a lot of imaginary numbers. There's one thing that neither you or your brother have asked about. I've got to believe they've talked about this. What's that equal to? Any idea?
No.
Okay, i's go in multiples of 4. Here, I'll write this a little different.
Uh-huh.
See the pattern?
Oh, yeah.
So when they give you one, whoops, this was -1, this is minus I.
And then 1.
8th is 1. So when they give you one like that, what you want to do is take out as many multiples of 4 as you can. Well, that takes you up to 200. So this is really the same as I cubed, which is the same as minus I. Because I cubed is I squared times I, and I squared is -1.
Okay.
Okay? So what is this equal to?
It's the 14th. That's a multiple of 7. So.
Oh, you want to take out multiples of 4. How many multiples of 4?
So 3.
Okay, what's left over?
I squared.
That's always how you do it. Whatever the remainder is, after taking out as many multiples of 4, like up here, the remainder was 3. Down here, the remainder is 2. So divide it by the maximum multiple of 4 that you can and use whatever remainder you get. So I to the 12th, you can pull out all of them. There is no remainder. That means it's equal to 1. That's equal to 1. Yeah, anytime it's a perfect multiple of 4.
Then it's just 1.
Yep. And you know what? That's it in terms of imaginary numbers. It's really not that broad of a subject. There's one other part. Maybe they've taught you, maybe they haven't. And that's graphing them.
No, we haven't gone over that.
Well, it's pretty straightforward. If I have an imaginary number, 3 plus 2i, the horizontal axis is the real part.
Which is
The
3.
vertical axis is the complex part. So I would go to 3 and up to 2, and that point would be 3, 2i. Actually, excuse me, it would be 3 plus 2i, not comma. Not like the xy. In other words, any point that you can define with the a plus bi format can be graphed on the complex scale.
Right.
And man, if I was teaching a course on complex numbers, I'd be done, because I can't think of anything else to talk about other than adding them, multiplying them, dividing, subtracting, turning them into a proper format, and being able to take powers of I.
Yeah, that's about all we went over.
Okay. You have any problems on your homework or review material that isn't one of those things? There might be some stuff I'm leaving out, but I don't think so. The only one that really has mystified me for a long time is the one I gave you.
-7 and -2.
Well, whenever you have 2, that's an imaginary number, so is that. So you want to convert it before you multiply, not after.
Yeah.
Same thing with dividing, incidentally. That is not equal to the square root of 7/3.
It's negative.
Yes, it's equal to negative square root of 7/3. But you actually have to do them, in other words, convert each of these to i's first before you figure this out. If you use the general rule that the square root of a divided by the square root of b is equal to the square root of a over b, it turns that -7 over -3 into a positive number. And then you don't get the negative in front. So whenever you're multiplying or dividing, you got to be a little careful to always turn it into an imaginary number before you do anything else.
Okay, makes sense.
Okay. Jessica, if you don't have anything else, I will let you go.
Thanks. Thank you.
Okay. Talk to you next time.
Yeah.
Bye-bye.